Next, I'd like to introduce MPLS OAM. MPLS OAM supports proactive OAM and on-demand OAM, which provide 10 OAM functions. The next section will focus on some key functions. First, CC and RDI. CC is used to detect unidirectional connectivity between a pair of maps, which periodically transmit and receive CCM frames to achieve CC. In this figure, CC-enabled Map 1 transmits CCM frames and Map 2 periodically receives the CCM frames from Map 1. If Map 2 does not receive a CCM frame within an interval of 3.5 times Map 2's CCM transmission period due to a link failure, Map 2 reports an LOCV alarm. The LOCV alarm clears after the faulty link recovers. If a received CCM frame is not the one expected, an alarm is reported. Map 2 detects an LOCV alarm and transmits an RDI frame to Map 1. After receiving the RDI frame, MEP1 reports an RDI alarm. The RDI function is used to report a remote end fault when the CC function is enabled. An LB test is used to check bidirectional connectivity of links between a map and an MIP, or between a pair of maps. In this figure, Map 1 initiates an LB test to Map 2. First, Map 1 transmits an LBM frame to Map 2. After LBM frame reaches Map 2, Map 2 returns an LBR frame to Map 1 through a reverse channel. If LBR frame reaches Map 1 within a specified time, the bidirectional connectivity between Map 1 and Map 2 is normal. An LB test can also be used to test the bidirectional connectivity between a map and a MIP. In this case, the LB test must be initiated by the map, and the TTL must be set to the number of MIPs between the map and the destination node. In this example, the TTL is set to true. An LT test is achieved by a series of LB tests that are implemented from near to far. It is used to obtain adjacency relationship between a map and a MIP. in the transmit direction of a local map. LM can be performed in two ways: dual-ended area and single-ended area. Next, I will introduce the principle of single-ended area. In this figure, the local map 1 periodically sends an LM frame to its opposite map 2. An LM frame contains the TX-FCF value, which is the value of local counter TX-FCL at the time of LM frame transmission. When receiving the LM frame, map 2 transmits an LMR frame. An LMR frame contains the following values: TX-FCF, value of TX-FCF copied from the LM frame; RX-FCF, value of local counter RX-FCL at the time of LM frame reception; TX-FCB, value of local counter TX-FCL at the time of LMR frame transmission. Upon receiving the LM frame, map 1 uses the following formula to calculate near-end and far-end packet loss counts. In the formula, TC is reception time of current LMR frame and TP is reception frame. Map 1 uses the following formulas to calculate frame delay. The value generated by this formula contains the time. The opposite node handles the DM frame and serves as input for frame delay variation measurements. The value generated by this formula does not contain the time the opposite node handles the DM packet and is more accurate.